Okay. Right, for section 19C, there are I think 18 questions. Extended response. I'm assuming all of these are calculator questions, and it goes up to 18. Now I think out of everything, only question 18 is the confidence interval one. The rest of it is not confidence interval. But many of the other ones are actually relevant to chapter 16 and 17 as well. But definitely the harder ones. Yeah, the harder ones in chapter 16 and 17. All right. I think the first few questions are from chapter 12, optimizations, and then the next few ones are trigonometry, and some of them are also optimizations. Some are really difficult ones. I've seen a few very difficult ones in this chapter. Now, note that these questions are mostly complex unfamiliar, so they look kind of long. Right? It's essentially what they're testing is your ability to understand the question, understand the context, and then form mathematical equations for the context. Okay, so it's like really intense problem-solving type questions. So let's have a look here. Question 1. Let's get started. Let's see how many we can go through today. All right. A Queensland resort has a large swimming pool as illustrated. With AB is 75. Okay, I should put in 19C first. With AB equals to 75. Let's put that information in here. And AD is 30. Put the information in here. A boy can swim at 1 meters per second. Okay, so that's a swimming speed, 1 meters per second, and run at 1 2/3 meters per second. He starts at A, swim to a point P, and run from P to C. So the path is like from A to P and then from P to C. Okay, he needs to get from A to C, and then he takes 2 seconds to pull himself out of the pool. So this is a constant. 2 seconds, right? It's constant. Regardless of where P is, it's always 2 seconds. Let dp be x, okay, so we're saying that dp here is x, and then the total time taken be t. Show that t equals to that expression there, and then b, find dt over dx, which is the derivative, and then c, find the value of x for which the time taken is a minimum. When you see that, you think derivative, right? And then find the minimum time. It's basically substituting x in to get the time. And then find the time taken if the boy runs from A to D and then from D to C. Just to see if purely running from A to D and D to C is going to be faster than swimming a little bit and then running the remainder of it. Okay. All right. So that's the context of this question. Not too bad, right? Any questions so far, Stephen? No. Pretty easy. Yeah. Now let's look at the actual math. First, when you see show that question, what do you do?
Go to the next one.
Very good. You go to the next one. Okay. We start on the next one. I'll put question A here. Do that later. Now let's start on question B. Find dt over dx, so let's use the result there, and I'm going to write t equals to x squared plus 900 to the power 1/2. I'm going to go a little bit faster. Okay, see if you can follow my my algebra, and then plus 2. So dt over dx, so derive the first one is half times, and then derive what's inside is 2x times by x squared plus 900 to the power -1/2. And then derive the next one, constant is the same, which is 3/5. Derive what's inside, you get -1. And then 2 is gone. All right, simplifying that should be just x, and then x over square root of x squared plus 900. And then minus 3/5. All right, so this is going to be like the simplest way of getting the derivative, dt over dx. Okay. All right, and then part C is find the values of x for which the time taken is the minimum. So time taken is a minimum means that dt over dx is equals to 0. And remember, we might need to check whether the at that point is actually a minimum or not. Because if we get two answers, we need to make sure which answer will give you the minimum, right, and which one will give you the local maximum, or even stationary point of inflection. So we need to test it. Well, but let's just get started with this one first. So 0 equals to x over square root of this thing. Okay, and then minus 3/5. Bring the 3/5 over there. I get this part here, can't do much about it. I can't write anything shorter than this, it's not safe. And then do the cross multiply. I will get 5x equals to 3 square root of x squared plus 900. To get rid of square root, you square both sides, so that'll be 25x squared equals 9 times into this expression here. Okay, multiplying that in, so 25x squared equals to 9x squared plus 9 by 9, 8100. Subtract 9x squared both sides, that will be 16x squared equals to 8100. Okay, and so a square root, now you can square root both sides, but actually I'll just divide both sides by 16 first. Okay, so if I want to divide by 16, I want to, and I see like the 100 here, I will actually split that up into that times that, and the bottom is 4 times 4, right? Yeah. Which means 104 will cancel out, that'll be 25, and this one will cancel out, so that'll be 81 times 25 over 4. So far, it's still, these are all still perfect square, which means I can go x equals to plus minus square root of that, which is just essentially 9 times 5 over 2. Yeah. Okay, much easier if you break it down like that. Right, which is then plus minus 45 over 2. So you see, if we actually just try to square root that, I think it's not going to be as easy. Potentially, it's not going to be as easy as splitting that up first. So you see the technique there in a non-tech. So I know I said tech active, but I would like to rely on my non-tech skills whenever I can. Okay, so plus minus 45 over 2. Now, which one makes sense? X is the distance here, right? So, well, it can't be negative, which means we only take the positive answer. So x is equals to 45 over 2, since x must be greater than 0. Okay?
Yeah.
All right, so x is 45 over 2. Now, how do we know whether this is going to be a local maximum? Well, I think we can, local minimum. I think we can assume that it's a local minimum, right? Because there's only one stationary point, and they're asking, what's the value of x for which the time taken is a minimum. If you want to test it, you can still test it with the second derivative, but in this case, I'm just going to assume that it's going to be a minimum. Another way to test it actually is to test the value before and after. Okay, so test. If you want to test this, I would go test nature. So normally I would use the second derivative with this one, but when I see that, I see quotient rule. I don't want to do quotient rule. So I'll just go f dash at a value before that, which is 0, right? Yeah, a 2 stationary point, as long as I don't go into the negative 45 over 2, I'm still okay, right? Because the bound is like negative 45 over 2, and then positive 45 over 2. These are the 2 stationary points. We don't know what it is. It could be that or that or that or that. Right, but we know that there are 2 stationary points, and I can choose a value to the left, which is 0, and value to the right, well, let's go 50 or even 100. Around 100 makes the numbers a bit easier. All right, we'll see. Would it be easier? X squared plus 900. 900 is 1000. Yeah, no, that should be okay. So f of 0 would be 0 over that whole thing, over the whole square root, minus 3 over 5. Which is going to be less than 0. All right, so it'll be negative, so that will come down like that, and then it's a stationary point, right? And then f dash at the point, let's see, which one will make it easier? Square root of 900, right? So right now we have x squared, so I want to choose a value that make x squared plus 900 something that we can square rootable, basically. All right, but okay, let's just say that this is a non-calculator one. Then 900, the next one up will be, it's a little bit tricky. Okay, let's see. So 900, and then if it's 10 squared, it will be 100. 20 squared is 400. 30 squared is 900. 30 squared is 900. Yeah, that's when x equals to 0. All right, I'm just gonna go 100 and see how we go. How we go with that. 45 over 2. Okay, so that f dash at 100 would give me 100 over square root of 100 squared, which is 10,000, so 10,900, right, minus 3 over 5. Okay, so let's see, so 100 over this one. Now note that 100 squared is roughly 10,000, right? So I can change that one into square root of 10,000 over 10,900. So as you can see, the ratio of 10,000 over 10,900, right, is closer to 1 than 3 over 5. Does that make sense?
Yeah.
Yeah, because if you change that to 3 over, if you change 3 over 5 into square root of that would be 9 over 25.
Yeah.
Right? If you make the bottom into 10,000, which is you times by, I think, 400. Yeah, 400 times the top and bottom by 400. The top would be 3,600. So this will be 10,000. So 3,600 over 10,000. And square root of that, when you're subtracting by square root of 10,000 over 10,900, it's going to be more than 0. Right? Because the denominator is almost the same, but then the numerator is definitely way smaller on the right hand side. So it will be positive. So you can say this one is more than 0. Because of that, it comes up, therefore it's a minimum point. Okay? Even if you don't do this testing, I think it should be okay for this question because there's only one stationary point and they already say that is a minimum distance, all right? A minimum time. So we're gonna roll with that. Okay, and then that means the minimum time would just be part 2 is t at 45 over 2. So at 45 over 2, t equals to that equation there. So I'm just going to borrow that square root of 45 over 2, everything squared, plus 900. Okay, and then what was it? Plus 3/3, 75 minus x was 2. So plus 3/5, I think, and then 75 minus 45 over 2, plus 2. Okay, so note that I've been working this using basically tech-free. Okay, I'll show you guys the version to use tech-active later, but I think this one more likely to be tech-free. So note that when you guys are doing these questions, as I said, assume to be tech-active, so you can practice your calculator skills. Assume to be tech-active, but if I can do tech-free, I'll show you guys a tech-free version because if I can do tech-free, most likely it's tech-free. Yeah. So yeah, anyway, this one would be work through that. So this one would be square root of 45 squared. Probably have to multiply that over here. 5 to 20, 22, and then 20, 18, 2025. Okay, so 20, 25, and then plus, so that's over 4. So I'm going to make this one 3,600 over 4 plus 3 over 5 by, now 75 and 45, I want to take out 5 as a common factor. So it's easier to do the subtraction. So if I take out 5, the 75 would become 15, and then 45 would be 9 over 2. All right, note that the 5 here will cancel out, so it's quite convenient as well. And then plus 2, so that would be, square root of that would be 5625 over 4. So square root of 5625 over 4 plus, and then 2 times 15 is 30 minus 9 is 21. So 3 times by 21 over 2 plus 2. Okay, 3 times 21 over 2 plus 2. Okay, let's see. Oh yeah, that's right. Okay, now 5625. If you have a question like this, the easiest way to work through it is to factor 3. Okay, and don't think too much. If you can see any number you can divide by, let's say 5, just divide it straight away. Because as you keep on dividing it, the answer will become a bit more transparent. 1125, and then you can divide by 5 again. Would be 225, divided by 5 again, would be 45, and that would be 5 and 9. So square root of that would be square root of 5 power 4 times 9, so that will be 5 squared times 3 over 2. Does that make sense? Yeah? Because 5, okay, I'll write. Maybe I'll write.
Get rid of the square root,
Yeah, to get rid of the square root, right? That would be 5 power 4 times 3 squared over 2 squared. Okay, and then this one would be 63 over 2 plus 2. So that would be 5 squared. That would be 25 times 3 over 2 plus 63 over 2 plus 4 over 2. Okay, so 25 times 3 is 75. 75 plus 63 plus 4, and then half of that. So that would be 138. 138,142 over 2. So that's 71 seconds. Okay, so 71 seconds is the time taken if he tries to swim a little bit and then run across. Now for question D, find the time taken if the boy runs from A to D and then from D to C. Well, that means that the time taken here, I'll just quickly do question D here, it's not too bad. Question D, if it's purely running, right? So the speed would be 1/2/3 times by the distance run, which is 30 plus 75, right? Because it's just run across from A to D and D to C. So 1/2/3, that would be 5/3 times by 105. And then I will divide by 3 first. So divide 105 by 3, that would be 35. And this one cancels off. Meters per, oh wait, sorry, my bad, it's not times. Meters per second, so if you want to get the second, it will be this number and then divide by 1/2/3. Yeah, you divide by the meters per second, yeah, divide by the speed in order to get how long you will take. So that's 105 and then times by the reciprocal, 3/5. Okay, 105 divided by 5 first is going to be 21 times 3 is 63 seconds. This is actually shorter than 71 seconds. It's actually shorter than the time taken if you wanted to swim a little bit and then run. Okay, so you see the significance is that from A to P, so the interpretation is from A to P, the speed is only 1 meters per second. So even though the distance from A to P is shorter than AD and DP, right? Because that's the hypotenuse in a right angle triangle. It's always the shorter distance than the other two combined. But because the speed is so much lower, he might as well just quickly run across from A to D and D to C. Yeah. So that's that question there. Now for question A, show that the time taken. Now, in order to do this, well, actually it's not too bad. Just need to remember AP, so the time taken would be 1, again, it will be the distance AP divided by 1/2/3, right? Yeah, and then plus the distance PC divided by divided by 1, so that's the swimming speed, and the other one is 1/2/3. That's it. And then plus 2, because 2 seconds to get out of the pool, right? So based on this one, know that AP is just square root of 30 squared plus x squared because it's just the Pythagoras theorem, right? And then PC is just 75 minus x, right, over 5/3. And so the first one would be 9, you can rearrange it, x squared plus 900. And then the other one would be plus 3/2, so 3/5 divided by that is times the reciprocal, that minus that, plus 2, bracket shown, done. Okay, so it's not too bad. Right, the thing is with these show that questions, right, because most of the time it's not too bad, you don't get that many marks, like 1 or 2. So if you have time and if it clicks, you will be able to do it easily, right? And the technique is you need to draw into the diagram, right? So the easiest is to bring a bunch of pens and markers. So see, I have let's say if I draw it with a black pen, it would still be okay, but I think blue will be better. Are you allowed to use blue pen in the exam?
Yeah, blue and black.
Blue or black, right?
Yeah.
Then use blue, because most of the time the text is printed out black. Right? If you use blue, your writing will stand out. Right? And you can see. Otherwise, imagine if I start writing in black, like 75, it starts blending in, and you don't know what is it that you annotated into the question. Right? So yeah, blue and black. Can you use green? Are you allowed to do anything? Well, on the question paper, it should be okay, right?
For the internal probably, but not on the external probably.
I mean, in the answer, you have to use blue and black.
Yeah.
Right? But I'm talking about the question paper. You can annotate it with whatever color you want.
Yeah.
Okay. So if you want to highlight certain bits using highlighter, that's handy as well. So bring multiple colored highlighters, like at least 2. Okay. So you can highlight certain things. The thing is, when you start drawing into it, sometimes it's hard to see what's underneath. But if you highlight, at least you can still see it. Okay. So that's why I would highlight that section there, like this section here, without and not like if I were to draw using blue pen, it's still not that easy to see, if you know what I mean. Okay, so bring a highlighter into a math exam. Sounds funny, right? But it's really handy.
Yeah.
So that's question 1. Too easy?
Not bad.
Not bad, yeah. Yeah, so this is just essentially optimization question. It's not too difficult. Okay, some of them are much harder. We'll get to them in a second. Okay, this is the start of something that is a little bit harder. Okay, a little bit, but not too difficult. It's only hard because this is trigonometry. It's one of those things where you get multiple answers. Right, and you need to know the domain and range and all that jazz. Okay, so consider the function f given by fx equals to x sine x. So again, I want to highlight the function, so I can always locate that. There is a domain. If there is a domain, then most of the time there will be some sort of like multiple solutions, and you need to know how many answers, yada yada, right? And if you see that at this point, even without looking at anything else, right? Sine x, so no change in domain, right? So if we look at this, whatever we're solving, right? Most likely there will be how many answers?
8.
8 answers, yes, because that is 4 cycles. I would note it in here, 4 cycles. Okay, maybe I'll start writing in blue pen so you guys can see how the blue pen will sort of help, assuming it's only blue and black. Find f dash and f double dash. Well, we've got f here equals to x plus sine x. So then I derive that. F dash would be 1 plus cos x. Okay, and f double dash would be 1 is 0, so negative sine x. All right. These are the results for question A. Easy. Show that f dash of x more than or equals to 0 for all x. How do we show this? Question B. Show that the first derivative, note that f dash x is 1 plus cos x. How do we show that this is always more than or equals to 0?
Because no matter what the answer is for x, it'll always be 1 added onto it. So it's like 0x, 1x, like
No.
like 1 cos, 0 cos. Like, you know what I mean? I don't
Okay,
know.
you have to word it this way. Cos x has range of what?
0 to 1.
Negative 1 to 1.
Oh, negative 1 to 1. Oh.
Cos of anything is negative 1 to 1.
Yeah.
Sine of anything also has a range. Remember, the cos and sine function is always like that, and the top is always 1, the bottom is always minus 1 for the original cos or sine function, yeah? So cos x or sine x. Sine x is just cos x and then shift it, right? But ultimately it's still periodic function, so it goes from negative 1 to 1. If you have 4 cos x, that means it will shift to 4 and negative 4, right? That's an amplitude change. Okay, but the cos function only goes from negative 1 to 1. So since cos x has range from negative 1 to 1, 1 plus cos x has range, because you are plus 1 to everything, 0 to 2. Therefore, f dash of x is always greater than or equal to 0.
Yeah.
Okay, you have to actually use mathematical reasoning.
Yeah, I know.
Okay, and the key is the range, using the idea of range and domain. All right, next is question C. So question C is solve the equation f double dash equals to 0 for that one. So f double dash equals to 0, which means negative sine x equals to 0. Therefore, sine x equals to 0. Therefore, what are the answers?
Is it 0? 0? First one? Pi? 2 pi? 3 pi?
Yeah, so you see, when sine equals to 0, it's always multiples of pi. So that's 0 pi, that's 1 pi, that's 2 pi, and then that's 3 pi and 4 pi, yada yada, right? For sine equals to 0, it will be these 2 points, right?
Yeah.
So if you recognize that, oh, hang on, that means you just go 3 pi and then 4 pi, and then you gotta go negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi. How many answers are there?
There's 9.
9. Does that seem normal? No, because this is the only case that you get 9 answers. You get one more than the normal case.
Yeah, because you have to start at 0, right?
You have to start at 0, yes. And 0 and 2 pi is the same angle.
Yeah, okay.
Right? And so 0 and 2 pi, they are both a solution. They're both solutions. So the first 3 solutions actually has an extra 0 solution. That's why it's more than just just the standard 8 answers. So that's why I wrote 4 cycles, but not 8 answers, right? Yeah. So when sine equals to 0, that's the only case, right? That's the only case sine x equals to 0 where you normally would have one more than the standard number of answers. So sine equals to 0, remember that. All right, so yeah, so that's the solution for all of that. Next is find the coordinates of the stationary points of inflection. Stationary points of inflection. Stationary points, but also inflection points. What are the coordinates of the inflection points?
Like all those points there?
Yes, correct. These are all, these ones are all x coordinates, of the points of inflection. Some of them may not be stationary points, right? But this is point of inflection because the second derivative is equal to 0. So then when you solve for the first derivative equals to 0, you will get the stationary points, right? Stationary point is when the first derivative is equals to 0. So we set that equals to 1 plus cos x, right? So then negative 1 equals to cos x. What are the answers?
Negative 1 cos.
Yeah, what are the answers for?
Pi. It would just be the same, pi.
It will be the point on the left only.
So pi, 3 pi, like that.
Yep. It will be pi.
Negative bounds as well, don't we?
Sorry?
Don't we need the negative ones as well?
That's right. That's why it's negative pi, negative 3 pi. Because there's only one answer per cycle. That's why there will only be 4 answers in total. For cos equals negative 1. Right? And this is the only case where you have only one answers in a standard cycle. Okay? When cos x equals to positive 1, right? Then x would be either 0 or 2 pi. Okay? Because it will be the point on the right here. And then for any other values of cos, let's say cos equals to 0, for example, then x could be either the point on top, which is pi on 2, or the point at the bottom, 3 pi on 2. It's 2 standard answers, right? So the only answer that there will be only one answer for in the entire unit circle in the standard domain from 0 to 2 pi inclusive. In the standard domain, the only one that has only one answer is cos x equals negative 1. There's only one answer. X is pi. There's only one point where cos equals negative 1 in the standard cycle.
Yeah.
Okay? So visualization looks something like this. So this is the cos. Well, the cos graph looks like that, right? There is only one point where the y value is equals to negative 1.
Yeah.
Okay? As opposed to the sine function, there are 1, 2, and 3 points where the sine value is equals to 0. Okay, so these are the two special cases. Cos equals negative 1, which is, you see, this question they ask you the exact two special cases for sine and cos equations. Cos equals negative 1, only one answer per standard cycle. Sine equals 0, there's one extra answer for the entire set of answers. Okay, yeah, so that's why this question is a little bit tricky because of the trigonometry. But yeah, otherwise it will be this one. So therefore, stationary point of inflection is where?
Just the. How do you match them?
You match them. It's because if you look at this, we're just looking at multiples of pi. So that'll just be negative pi, negative. Well, rather in the increasing order, negative 3 pi, negative pi, pi, and 3 pi. Yeah. 4 answers.
That one's easy.
Alright, so then the y values would be, when you put this back into the original equation, it's x plus sine x. Alright, so when you put negative, so sine of all of these would be 0. Right, because we just solved that here. Sine of that would be 0. And the original equation is fx equals x plus sine x. So when you put anything into all these answers into sine x, you get 0. So the answer will just be the x value.
But isn't that one the x coordinates and the one we found the y coordinates?
No, these are the x coordinates, yeah. And now we're trying to find the y coordinate. So if you substitute negative 3 pi into the first equation, that will be that plus sine of negative 3 pi. But what did we say for sine negative 3 pi? Like for all these points, for all of these points, the sine value is always 0, right? For the sine axis, it's always 0. For all of the points that we just found. Therefore, this next section will always be equal to 0. Which means the answer is just negative 3 pi. And then following the pattern, it will just be negative pi, pi, and 3 pi. Therefore, the stationary point of inflection will be negative 3 pi, comma, negative 3 pi, negative pi, comma, negative pi, and pi, comma, pi, and 3 pi, comma, 3 pi. Right? To do this question quickly, you need a little bit of reasoning in order to work through these questions a bit faster than usual. All right, now let's try this. The next one here. Consider the next graph. Gx equals to that, and then we got a redo that one here, and then we got a new domain here. How many cycles?
2.
2 cycles. All right, 2 cycles. So standard will be 4 answers. Let's see. Gx equals x over 2, and then you solve g dash equals to 0. All right, let's see. Gx equals 1 over 2 sine x. Let's rewrite that here. Gx equals 1 over, was it x over 2?
Yeah.
Just x over 2, right? Yeah. X over 2 plus sine x. Okay, so we have to solve g dash equals to 0, aka they're asking us to solve for stationary points. So remember, when you're doing questions, you always have to think, what does that mean? What else does that mean? Right? So don't just focus on doing the question. You focus on the concepts behind it. Like, why are they asking the question? What other concepts could they potentially put in this question here? Because if you keep on reminding yourself those concepts, you don't need to do anything. But in your brain, it's like the neurons will like connect better. You'll be like, oh yeah, that's right. F dash equals 0, stationary points. Right? And then you can do the nature, blah, blah, blah. Okay? The more you do those things, the easier that idea will come to you.
Okay.
All right? So it'll be 1 over half plus cos x. All right? So that equals to 0. Okay? And then I said that earlier, right? There will be 4 answers. So see, that's the idea of how you can practice your techniques without even like having to do the questions. Just try to remember what techniques will be related to these questions. So cos is negative 1/2. So this is most likely tech-free again. 1, 2, square root 3. Cos must be this angle here. And we're talking about radians, so it's pi on 3. But cos is negative 1/2, which means that in the cos axis, it must be pi minus alpha and pi plus alpha. All right? You gotta get the idea that fast. So then x would be pi minus pi on 3. All right? And pi plus pi on 3, but note that this is in the standard cycle only. We need the negative version of that as well, and the negative version is just the negative of these. So it's negative of pi minus pi on 3, and would it be negative?
Yeah, would it?
Yeah, it would just be the same thing, but like you turn into the negative region here. So with negative pi plus, yeah, same thing. So negative of pi plus pi on 3. Okay? So yeah, so that would be 2 pi on 3. 3 pi plus pi, 4 pi on 3 minus 2 pi on 3 minus 4 pi on 3. Yep, so that's just the solutions for the g dash x. And then find the coordinates of the stationary points on the graph of g. So we are solving for the y value as well as the x value. So now we need to go g of 2 pi on 3. Okay, if you don't see it straight away, that's okay. But if you recognize it, if you study the 2 equations, right? The only difference is that one is sine, one is cos. Okay, so when you substitute, note that we solve this, the cos value for this is always negative, but the sine value is not always negative, right? This one would be positive, this one would be negative. Yeah? And that's why when you sub it in, you get some positive, some negative. So if you're not confident, just sub the values in, and then see if you can work that through. But note that what you want is to see what quadrant it is, and the answer is going to be just sine of pi on 3, which is square root 3 over 2.
Yeah.
Okay, so then x over 2, so half of this number, which is times 2 in the bottom. So 2 pi on 2 pi on 6, and then plus sine of that, so that would be positive root 3 on 2.
Yeah.
Okay, and then g of, so this one will be the same as negative 4 pi on 3. Right? Because that angle there would go to the same point, negative 4 pi on 3 there. Okay?
Yeah.
Does it make sense? Yeah. So it goes to the same point. That's why this is also the same as g of negative 4 pi on 3. Okay? And then therefore g of, let's say, positive 4 pi on 3 is in the third quadrant here. and that would be the same as g of negative 2 pi on 3. It's also in the third quadrant, right? Because when we're talking negative, you turn that way. Okay, and that would be that would be 4 pi on 6. Oh, hang on, let's see. No, not quite, my bad. It's not going to be the same because there's an x component. Yeah, my bad, there's an x component. Okay, so yeah, let's just, this question is a bit tricky, so let's just fully work it out slowly. So that'll be 4 pi on 6 plus sine of that would be negative square root 3 on 2. Okay, so this the sine value of, let's say, negative 2 pi on 3 will be the same, but then the x, there will be an x divided by 2 component to that. So that will be negative 2 pi on 6 and then plus, right? Sorry, negative 2 pi, that'll be on the other side. So minus 3 root 3 over 2, and then g of negative 4 pi on 3 would be in the second quadrant. So that'll be negative 4 pi on 6 and then plus root 3 on 2. Okay, make sense?
Oh, yeah, wait, how do you get the root 3 on 2 and plus and minus? I understand the quadrant bit, but can you just explain it again?
Yeah, so sine, right? If I'm looking at this one here, I'm looking at the sine axis, and negative 2 pi on 3 is here. Right, it's in the negative region of the sine axis. Right, because in the sine axis, this is positive, this is negative.
Yeah.
Right, for this entire region. Right, and then negative 4 pi on 3 is, again, you turn from here, you turn negative 1 pi and then add a little bit more, so it's in the positive section of a region of the sine axis.
Oh, yeah, makes sense.
Yeah, and then the other two are the same. Yeah, and then you need to make your conclusion, right? Therefore, let's say the first point 2 pi on 3 and put the y coordinate 2 pi on 6 plus root 3 on 2, and then the second point is 4 pi on 3, put the y value 4 pi on 6 minus root 3 on 2, and then negative 2 pi on 3, the y value is negative 2 pi on 6 minus square root 3 on 2, and last point, negative 4 pi on 3 would be negative 4 pi on 6 plus square root 3 on 2. Yeah, these are all the points. All right, final answer for question 2. You see, the algebra is difficult because of the trigonometry. So you guys have to go and practice this. But if you're comfortable, you should be able to do this one in like 15 minutes. Yeah. 15 to 20 minutes. I think I took 20 minutes, but it takes some explanation. If you don't need to explain, and just be like, oh, right, work the answer out. Aim for about the time that I took, or even ideally half of that. Right? Because if I'm just writing, I can get this done in like 10 minutes or less. Okay. So that's what you guys should be aiming for. Next question. Question 3. Okay, for this triangle here, so looking at this triangle, I know it's going to be chapter 13, which is the trigonometry chapter. All right, let's see. For triangle ABC, A is 30 degrees, and then the side A is 60 and C is 80. Okay, so already put the values in there for us. Quite nice. Find the magnitude of angles BCA. So BCA is this one. Let's call that alpha. And then ABC, right? Let's call that beta. Okay. And then we need to find the other angles BC dash A, which is this one here, and ABC dash. So we need to mark another one here. Oh yeah, maybe I'll just use the name of these angles. Or you can go this one alpha and then this one gamma if you really want to name all the angles that they're asking. Okay. All right. Okay, and then there'll be more angles later, but I think we're running out of letters here, so we'll just stop there. All right. So for question A, find BCA is essentially, what rule are we finding? What rule are we using here?
Cosine rule.
Cosine rule. Do we have two sides and an included angle? Cosine rule is only usable when you have two sides and an included angle, all three sides. Yeah. Now the trick is to recognize, start with the angle, see if the side is known. Yes, it is known. And then you look at the other angle and see if the side in front is known. Yes, it is known. Right? So if you have two pairs of the angle and the side in front is known, you can use the sine rule and cosine rule. Sorry, the sine rule. So this one would be sine, I'll rewrite it here. So sine alpha is equals, sine alpha over 80 is equals to sine 30 degrees over 60. Definitely calculate a question. So alpha would be, at this point, you can just write the answer. You don't actually need to write like the inverse sign and stuff like that, as long as you punch it in correctly. I think you get 1 mark for doing this already. Okay. You don't even need to write the intermediate step of like inverse sine of 80 sine 30 over 60. You don't technically need to write this. You get no marks for this. Right? If you need to, write this so it's easier for you to see the answer. But if you can just punch it into the calculator, then no point. Right? So I'll just punch it into the calculator if you guys are working through this on at home. And make sure you're in degree as well. So 80 sine 30 over 60. Alright? And again, if we're asking for two decimal places, so when you get a decimal number, check out how many decimal places they want. If they want 2, you need to start with 4. 41.8103 degrees. Okay? And then, yeah, so we'll just write it as 41.81 degrees to 2 decimal places as part of the answer. Or if you want, you can just write the angle. Angle BCA equals 41.81. That's a conclusion. But the number we use is this number later. Yeah. For any other calculation. Okay, and then the angle ABC, right? So the angle beta would be 180. Again, you don't really need to write this, but you can write that. So minus 30 degrees minus alpha. Just punch in the answer. Okay, so 180 minus 30 minus 41.8103. Again, use 4 decimal places. 108.1897 degrees. Then you conclude, therefore, the angle ABC is equals to 108.19 degrees. Okay, so because most of the time the answer will, if they say 2 decimal places, in the answer sheet will be 2 decimal places, and they check every single digit. Yeah. Okay, but of course you have to use the more decimal places. That's why you always write 2 versions: the more decimal place and the one that is specified by the question. Yeah. Okay, so that's question A1 and 2, A1, sorry. Now continuing, we've got A2. All right, BC dash A. Well, how do we find BC dash A? Do we what other informations do we know? What triangle are we using here? Which is angle gamma?
The big one, man. 30, 80, and 60.
Yep, 30, 80, and 60. That's right. So sine rule again, right? So sine of gamma over the opposite side, 80, and I'm talking about this triangle here. Okay, would be equals to sine of 30 degrees over 60. Once again, just punch that in. So inverse sine of 80 sine 30 over 60. Okay, so if you can, you actually can do this question really quickly. So that's 41.81. Oh wait. I see. Okay, that's why they answered. Okay, I missed one thing. So in the sine rule, sometimes the answer here would, in this case, the answer here we need to add another. Okay, let's see. We will need to do 180 minus that number because it doesn't make sense, right? Alpha is an obtuse angle. Like, why is it 41 degrees? Yeah. Okay, so this is the special case of the sine rule where the 2 sides are both 60. This one is 60, that one's also 60, but the 2 angles are one of them. So this alpha is correct. Sorry, the gamma is correct, but alpha is wrong. So fortunately, I was going too fast, but fortunately, they asked us to find another angle that's in the same situation. So in the sine rule, just remember when in some cases, be careful that the angle matches up with how it's supposed to look. So in this case, it's an obtuse angle. So alpha would be 180 minus that one. Okay, so be 180 degrees minus 41.8103. So I'll fix that one up, which is then, let's see, 138.1897. So therefore, the angle ACB is 138.19 degrees. Okay, there you go. That's better. Okay, so gamma equals that. Therefore, the angle.
Wait, you gotta change the other one as well, then, right?
No. Oh yeah. I do need to change this one as well. Yes, minus alpha, and just switch that up. 180 minus 30 minus that is 11.8103 degrees. So I'll change that one here. 11.81 degrees. Yeah, looks about right. Let me check. Question 3a is 11.81. Yep, yeah, that's right. 41.4. Yeah, that's right. 41.81 degrees here. Okay, and then ABC dash. ABC dash is just the just 180 minus the other two angles. So maybe I don't write this one as alpha. I'll just write angle ABC dash is equals to 180 degrees minus 30 degrees minus gamma. So yeah, as you can see, the convenient thing is that because I wrote gamma rather than the value, I can just like rub out the answer and then rewrite the value. I don't need to rewrite this entire expression. Yeah, so that's the handy thing about sometimes using notations rather than the actual value. So you only substitute the answer into your calculator.
Yeah.
Okay, so yeah, 180 minus 30 minus that. Let's see, what would that be? Okay, so that's that's the answer earlier. 108.1897 degrees, and that would be 108.19 degrees. Okay, so that's angle ABC dash. All right, let's write it in the final answer here. Okay, so that's the answer for A. B, find the length of the line segments AC, AC dash, and CC dash. Okay, all right. So one thing that I told you guys earlier is that when you're in a trigonometry question, when your diagram is getting a little bit too complicated, you should redraw it. Okay, in this case, I will redraw it. So AC, AC dash, okay, so and then CC dash. So first for AC, I will redraw that little triangle there, ABC. Right, so we've got A here, 30 degrees, 80, 60, and then we got the angle B, right, which is 11.8103 degrees. Okay, and then we need AC. All right. Since we need AC, we'll use the cosine rule, and I don't even need to put the 30 degrees in here.
Yeah.
Okay, so only put in what I need, and so that it's not confusing me. So using the cosine rule, AC squared equals to, you can just put the values in straight away if you can see it, 80 squared plus 60 squared minus 2 times 80 times 60 times cosine of 11.8103 degrees. And so you can just write AC equals to the answer. Right? You don't even need to write the whole square root stuff. It's just algebra. You don't get marked for basic algebra. Okay, just punch that in. 2 times 80 times 60 times cos of 11.8103. So AC is 24.5607. Unit is... what was the unit? Oh, no units. Yep, no units. Then we'll just leave it. Okay, then therefore AC equals to 24.56. Okay?
Yeah.
Let me double check them. Yep, that's right. Okay, so that's the first one, and then we apply AC dash. So AC dash is a different triangle. It will be ABC dash, right? So once again, I'll draw that triangle out. ABC dash. Doesn't need to be exact. Okay, ABC dash. Now, the angle ABC dash we found earlier was 108.1897. 7 degrees, and then we've got this one is 60 and 80, same thing. Okay, so then we've got AC dash is equals to, if you want, you can just go fancy and just go straight square root of, and then you put everything in here. I still recommend to write the formula first, because you get marks for the formula step. Because it's like, recognizing and using the cosine rule to solve for the side. That's like what the criteria would look like. So it's best to write this formula, and then you punch just the entire formula. And as long as you have a resemblance of the formula, right, they will accept that.
Yeah.
Okay? So yeah, so it'll be that one.
How do these see if you come looks unfamiliar?
Wait,
Okay.
not yet. It will come in a second.
Simple familiar.
Yeah, somewhat, yeah. Yeah. The
side.
the first tricky part is the one here where you need to recognize that this is 180 minus.
Yeah, that is the tricky bit.
Yeah, that's the first part there.
Yeah.
It's not part of the standard syllabus. Okay, and then yeah, let's punch that one here. The trick is you can use a calculator and just change up the angle in the calculator. You don't need to retype everything.
Yeah.
Yeah, 1897. So that will be 114.0034. Yeah. So that will be AC dash would be 114.00. Box that one up, 2 decimal places. Okay, and then continuing, we'll need to calculate CC dash. So CC dash would be just write AC dash minus AC. Right, so that would be, again, I will use the more decimal places, 114.0034 minus 24.5607 equals to 89.4427, which is 89. So therefore CC dash is 89.44 to 2 decimal places. Okay. So far so good. Now question C. Show that the magnitude of CBC dash is 96.38. How do we show this? In this question is one of those that normally I recommend you to skip, but this is so simple, you shouldn't skip this. Because in the normal exam, they will not tell you. They will just be like, find the area of BCC dash. They won't even tell you the magnitude of CBC dash. How do we find CBC dash?
CBC dash.
Grade 9 geometry.
If
it's too confusing, always redraw it.
It's like a, what's that, isosceles triangle?
Yeah, isosceles triangle, yes.
2 sides are the same.
Yep, CBC dash, CB is 60, BC dash is 60, and what else do we know? We know this angle, right?
Yeah.
BC dash C, or it's AC dash B, one of those things here. BC dash C, this one here. 41.8103, so that'll be 41.8103 degrees.
The other side is that, and then
It's also the same.
Yeah.
Okay, so you see in trigonometry, when in doubt, just draw a simpler version of the diagram. Sometimes you're overwhelmed by the diagram. So if you draw the version straight away, it took like 30 seconds drawing this.
Yeah.
Right? And then instantly see the answer as opposed to spending 2 minutes thinking. There's no point.
Yeah.
Okay? In math, don't be lazy. Just write everything out. The more you write, the easier it is. The only question children would have is, what do I do? What do I write? Well, you draw the diagram, you write down the values that you'll get, m equals something, k equals something, whatever, and write as much as you can, right? And then you'll be able to figure things out a lot faster. So yeah, so CBC dash would be 180 minus 2 times 41.8103 degrees. Punch that in. That should be the same, but I'm just going to get the more decimal place value. So that'll be 96.3794, which is the same as 96.38, and that is 96.38 degrees shown to 2 decimal places. Brackets shown. Okay?
Yeah.
Now, given that, we need to find what? We need to find the area. So look at the next few questions. This is the somewhat complex, unfamiliar, but it's just because they go all the way back to grade 9 geometry. If you don't know grade 9 geometry, GG. Area of the triangle, that's still math methods. Area of the shaded sector. What's a sector?
The cone.
The cone, yes. We see this whole thing, right? That's a sector, good. And then what's a segment?
Segment will just be the cone bit, right?
The
Just
blue
the
bit
blue
here.
bit, yeah.
Yeah, so that's essentially it. If you want, you can just draw out the little bit here to visualize it. So I'm pretty sure that's question E, is it? Oh, we're still on C. Oh, not even D yet. This is C. Okay, so that's the first part of C, and C1 would be the area of ACC dash would be half, right? 60 times 60 times sine of the angle, which is 96.3794 degrees. Okay, again, you have to write a formula to get the marks. So half AB sine C. So 30 times 60 times sine 96.3794 is 1788.8543, which is 1788.85 square units. Alright, box that one up. That's the answer for 1. 2, the area of the sector. How do we find area of the sector? Like the whole thing here.
Gotta do the cone formula, but I don't know. Can't remember what that is.
It's not a cone formula. It's easier than the cone formula.
Oh, half a circle plus the triangle?
Not half a... Well, no.
Quarter of a circle.
No. It's a fraction of a circle corresponding to the angle. Right? So normally, if you have like a full circle, right? The area would be pi r squared, right? If you have a certain angle theta, it's just a ratio, right? So the area of the angle theta would just be the ratio, which is theta over 360, right? And then you times pi r squared.
Oh yeah.
Right? Yeah. So that's why this one is the same idea. The sector is just going to be the angle CBC dash, which is 96.3794 over 360. That's the portion of the circle we are taking the area out of. And then times by 60, so pi times 60 squared. Okay, so once again, punch that in. 96.3794 times pi times 60 squared over 360. So that area of sector, right, would be equals to 3027.8482, which is 3027.85 square units. Okay?
Yeah, and the next one's just that one, subtract the top one.
Yeah. Now, the textbook actually gives me a different answer, and I think that's because they use a 2 decimal place version. Yeah, but normal, and that's because this question, I think they said use this angle using this value to find the area, but I don't think they will give you this kind of question in the exam. Yeah. So, and I think if you use like a higher decimal place, I think that should be okay. It's a bit rare, no? That they said to use a decimal value to like a specified decimal value. Because if you let me see, if you were to use the specified decimal value, I think you will get the one that they said. 0.87, yeah. If you use that value there, then you will get the one that they said. So I guess just be careful if they do say use a certain value, then you have to use that value. Yeah, because sometimes they'll be like, oh, use pi equals 22 over 3. Was it? Or over 7 or something. Yeah. Because sometimes they'll be like, oh, use pi equals 22.7. So you have to use that value. You can't use the calculator pi.
Yeah.
Yeah. So just be careful with that one here. So yeah. So this answer is a little bit different. The other ones are not that different. Okay. Then let's say if we were to actually use just their value 0.38, then 6.38. Yeah. Then that would be 0.87. This would be 0.87. Then the last one, because it's a subtraction, it doesn't really matter if you use the lower or higher decimal place. Okay, only multiplication and division will be affected by the number of decimal digits. When you're doing subtraction, you don't really need to. So area of segment, would just be the area of the sector, which is 3027.87 minus 1788.85. It's just basic geometry. So 1239.01, wait. Yeah, the textbook answer I think is way off. It's 0.01, but it should be 0.02 here. Why would they have 0.01?
Because you did to 96 points.
Yeah, it's weird because this one, if they use the rounded version and then they subtract the rounded version, there's no way you can. Yeah, there's no way it will, like the difference is going to be the same. So I don't know how they got that number. It's strange. But yeah, that one should be okay. Square units. Okay, I mean it's 87 minus 85. You can't get 0.01 there. Okay, that's it for question 3. Okay, we'll go through. So the first three are just easier, complex, and familiar questions. If you get the algebra, it's not too hard to get the concept. The next few ones though, so it's slowly getting a bit harder conceptually. All right. This one, question 4. To connect a house to a gas supply, a pipe must be installed connecting point A on the house to point B on the main, where B is 3 meters below ground level and at a horizontal distance of 4 meters from the building. If it costs 25 per meter to lay pipe on the ground and $10 per meter on the surface, find the length of the pipe, which should be on the surface to be minimized cost. Okay, so what do we do?
Put the 4 in first.
Okay, put the 4 in first and where?
Up the top. Oh wait, let me show you again to make sure. The figure is right, and at a horizontal distance of 4 meters. Yeah, but XB is 4. XB is 4.
XB is 4. Like 4 meters?
Yeah. Is that right?
Horizontal distance of 4 meters from the building means that is 4. Because otherwise, how do you know AX?
True.
Right? So they give you a strange formula, because if they ask the length of the pipe, which should be on the surface, right? So surface and so this is point B on the main, which is below ground level. Now this is a misleading question because that's a ground level. Right? This is not a slope, right? Yeah, you can't walk on here. Like your head would be at the ground level. Okay, so the ground level is like that.
Yeah.
Right. So they stop there, which I think is a little bit misleading. The first time I looked at it, oh, is it a slope? No, it's not a slope. Okay, like the entire section here is below ground level. This entire section there, because the main water line is, well, the gas supply, the main line would make sense to be underground, right? You don't see any gas supply on the ground. So that is why this is 4 meters, and so this would be 4 minus x. So we're actually solving for 4 minus x, right? If we put this as x. So it's actually a strange diagram here. Well, we'll go with that, but if I were to draw this diagram by myself, it would be a and then 2x, right? So that's, I'll draw all the ground level out first, and put that point as x, and then put that point as b. So I know where's underground, where's above ground. And then I'll draw this a little bit here because we're solving for the surface pipe. I'll draw this one as x, and then put this one here is 4, and then it's 3 meters underground. So then this one will be 4 minus x here. Okay, so I would personally prefer to draw it this way.
Yeah, okay.
So let's say we ignore that. Alright, we look at this diagram here, and then we find, so $10 per meter on the surface. Alright, so this is 10 per meter, and then this one is 25 per meter. Then what is the cost? Cost C would be equals to 10 times x, right? So 10 times AX plus 25 times BX. Okay, so start with the simple formula first. 10 times AX is just, we say that is x, so it just be 1x here. And then the other one would be, okay. So if we do it this way, then the BX will be a little bit harder because you got to go 4 minus x and then everything squared. Okay, so then that means I'll actually revert back to the recommended version and put the x here instead.
Okay.
Because bx, if you put x over at the location here, the bx would be a hypotenuse. So it should be x squared plus 3, be a bit easier. Yeah. Either way, you get the answer, but yeah, let's just follow the recommended version here. So sometimes, we can rearrange the question. Sometimes it's there for a reason. But trying both would give you a better idea next time you know which one to use. It's like learning how to use more tools. So 25 and then bx is square root of 9 plus x squared. Should be obvious by now.
Yeah.
Okay. Yeah. And this one would be 4 minus x.
Yeah, I was going to say, when the 10 change, yeah.
Yeah, that's right. Right. So cost would be that. And then minimize cost would mean you got to find dc over dx. And set that equals to 0 and then solve for x.
Okay.
Alright. Equals to something, and then set dc over dx equals to 0, solve for x. Yeah. And then find, and that's it, because we just and then find 4 minus x because it's the length of the pipe on the surface.
Okay.
Okay, so I'm not going to go through this, just algebra, not hard.
Yeah.
Okay, because we went through something very similar before. But establishing this equation is the unfamiliar bit of this question here. Most of our complex unfamiliar question is just establishing the equation. If you can get the equation, the rest is easy.
Yeah.
Okay, as long as you can do the CF assuming. Now, question 5. All right, we'll go through a few. Let's see, what time is it? Maybe we'll go through like 2 or 3 more questions, and then I'll pause the first half of the recording. I'll stop the first half of the recording. Adam notices a distinctive tree while orienteering on a flat horizontal plane. From where he is standing, the tree is 200 meters away on the bearing of 050 degrees. 2 other people, Brian and Colin, who are both standing due east of Adam, each claim that the tree is 150 meters away from them. Given that their claims are true and Brian and Colin are not standing in the same place, how far apart are they? Give the answer to the nearest meter. So, where do we start?
It's elevation. Angles of elevation, right?
No. There's no elevation in here. Read again.
He stands on a flat plane. He's looking towards a tree.
Yeah.
Oh wait, this is bearings.
This is the bearings one.
Oh, okay. Let's okay. So the tree's 200 meters away. So just draw it.
So bearing of 050. So what's the first point I put?
That way, 200 meters. Let's start on A.
Yes, you start on A for Adam, right? And then the bearing from Adam, which means you draw the north line there, and bearing of 050. So this is 50 degrees, and then this is a 3t, and this is going to be 200.
Yeah.
Right? And then Brian and Colin, who's standing due east. So I gotta draw the east line.
It's claiming that the tree is 150 meters away.
Yeah, how do we draw B and C, Brian and Colin?
They're just one person.
No, they're 2 people, but they're both 150 meters away from the tree.
Yeah, they're in the same spot.
No, they're not in the same spot.
Yeah.
Their claims are true, and they are not standing in the same place. How do we draw those? This is the unfamiliar part. You need to be able to imagine something. I won't say that yet.
They may be like east, but like on a different angle.
Yeah, that's right. You think circle. Because they are at equal distance, right? Because if you take the tree as a center of a circle, if you draw a circle, they're always equal distance from the center. So that means it will be something like that. Right?
I see.
Okay, because equidistance, which means it's going to form an isosceles triangle. Assuming this is 150, 150. Right? This is going to be B and C. And again, we don't know where B and C is, so that's why they just ask how far apart, because if they ask for like what's the distance between Adam and Brian, it's not obvious, right? It could be CB or it could be BC. But they don't care. You say how far apart are they, so you put that line there as X. Right? Between B and C.
Yeah.
Alright?
Yeah.
Now we're gonna solve for it. So putting what we know, 50, this will be 40, and then we've got these 2, which means that, can we find something out from here? Yeah, we have to use the sine rule.
Sine, yeah.
Right? To calculate this one. Oh, but see, when it's 150 and 150, remember, when you sine rule, the first angle you find will be the smaller angle over here.
Yeah.
Right? Yeah?
And then, shouldn't it be the same for B as well? Because they're both 150?
Yep, that's right. Yeah, so it will be the same. These 2 angles will be the same. So we actually, if we were to solve it, we actually get this angle, and then you can get the top angle here, alpha, or theta, for example, and then you just essentially use cosine rule to find x.
Yeah.
Okay? So once you've got the diagram and put all the points in, it's pretty easy now.
Yeah.
Okay? So I'll write the steps here.
Idea.
Okay?
It's just that circle idea.
It's that circle idea that you need to get it.
But now that I've seen it, it makes more sense for other questions.
Yeah, right?
Yeah.
And then you gotta use sine rule. So sine rule for the angle TCB, right? And then isosceles triangle. Isosceles looks familiar. This is like the same as the previous question, right? Isosceles triangle for the angle theta, and then cosine rule for BC. That's it. I'm not going through it because it's the same calculation as up here.
Yeah.
Remember this one?
Yeah.
Same thing. Actually easier because you don't need to calculate the area. Next, question 6. Oh, this is long. Okay, I'll go through bit by bit. 6A first. Cora is standing at point C. She can see a beacon due north at point B. She can also see a tower at point T, which is 5 kilometers away, bearing 56. The tower T is due east of beacon at B. Distance between beacon and the tower correct to 3 decimal places. Pretty easy, right?
Yeah.
What do we use?
Well, 2 angles on one side.
No.
What? 90 and 56.
No. When you see 90, what do you think?
What's it called? Just do C squared, B squared.
No. When you see 90 degrees, it's the right angle triangle. You think SOHCAHTOA.
Oh, yeah.
Okay, 90 degrees right angle triangle, SOHCAHTOA. Okay, so this is the opposite side of the angle 56 degrees, and we have the hypotenuse. Which rule? Sine rule. Sine 56 degrees equals to BT over 5. Okay, so BT is 5 sine 56 degrees, which then is equals to 4.1452, right, kilometers. And to the 2 decimal places, 4.15 kilometers.
Yeah.
Okay?
Yeah.
Wait, what? How many? Oh, 3 decimal places. Sorry, 145. So we need to go a bit more. 14519. There you go. Okay? Alright. So that's question A. Next, question B. If they break it down like this, it's normally make things a bit easier. So the longer questions are actually easier than the shorter ones. The short ones are the ones that they don't give you enough information. You gotta deduce a lot of stuff by yourself. Those are the harder ones. Okay, by looking at further 22 degrees east of the tower at T, see a radial mass at point M, which is 9 kilometers away. Find the bearings of the mass at M from C. So bearing of the mass at M from C. 22 degrees east from the tower at T. Oh yeah, okay. And then the distance from between the tower and the mast, correct to 3 decimal places. So tower and the mast, so TM. Look further, 22 degrees east of the tower at T. So they already put 22 degrees here, which means question 1, the bearing, right? So bearing of M from C is just 56 plus 22. 78 degrees. Okay, so note that it's 2 digits, so you gotta write 078. Yeah. Okay, and then find the distance between the tower and the mast, correct to 3 decimal places. What rule do we use?
Between the tower and the cosine.
Yeah, cosine rule, that's right. Okay, so basically it's just cosine rule. Cosine rule to find Tm. Right, pretty easy. Now let's see the last one. Cora now walks due east. How far must she walk? Okay, let's see. The thing is getting a bit more complicated now. Now, how far must she walk until she is at point S due south of the mast? Give your answer correctly 3 decimal places. What is the bearing of the mast at M from the tower at T? Okay, so from the bearing of the mast from the tower. So we're looking at this weird ass bearing there. Okay, now the first one. This is probably an unfamiliar bit. How far must she walk until she's at point S due south? Well, point S due south is not, this is not hard. We know it's 9 kilometers from C to M, right? Didn't we get that from here? Yeah, 9 kilometers away. Okay, yep. So that's 9 kilometers. Again, for questions like this, it's easier to redraw the diagram and see what else do we know. So this is 9 kilometers. That's C. What else do we know? Can we find out MCS?
Yeah.
Yeah, it's just 90 minus these 2, right?
Yeah.
So that's 78. So that will be 12 degrees.
Okay.
Okay. So how do we find how fast she must walk, which is CS?
You need to of the so-called total rules.
Yep. Which one?
We want to find the opposite, right? Wait, what are we trying to find? X.
X, yeah.
So, cos?
Yeah, cos 12 degrees equals x over 9 times 9 over 9. Cos 12 degrees equals x. Okay, let's work this one out. Do we need that? Maybe. 9 cos 12 is 8.80333 to 5 decimal places, and then that will be 8.803 kilometers to 3 decimal places, or CS.
Yeah.
Okay, right? What is the bearing of the mast at M from the tower at T? How do we find that strange bearing there? Yeah, how do we find that strange bearing there?
I don't know. Do we use the one before it, the M? Because it's 22 there. And then, wait, I don't know.
When you see an angle like that, you need to make it, turn that and break that angle up, or combine things, or turn that angle into a parallel angle of some sort.
Oh, yeah.
Because you can work with parallel angles, right? So, for example, in this case, if I were to draw that line there, right? Then when you have parallel lines, you can apply the parallel rules like the Z rule. And then you can start working things out.
Okay.
Okay?
Yeah.
So how do we work this one out though?
We could do the triangle. There's like that big triangle there to figure out that angle E or whatever.
Okay, alright. So we found CS to get to the south of the mass will be, what was it? 8.803, so 8.80333. Okay, and then we know the angle here is 12 degrees. Yeah, what else? How do we find, because if we can find this angle, it would just be that tiny angle there, and you add up to 90, you get the bearing, right?
Yeah.
Yeah, but how do we find that angle, P?
I don't know. Just redraw that triangle there? I don't know. Let's redraw that triangle. We've got 5 and, what's that? 33.2.
Wait, what do you mean 33.2?
Like, because 22 plus 11.2. Or whatever that is. Is that 11?
This is 12 degrees.
Yeah, this is redraw that triangle there. You got 5 and 34. Like 5 kilometers and then 34 degrees and then I don't know.
Oh yeah. So you gotta say which triangle? CTP. You're talking about CTP, right?
Yeah. Sorry.
Okay. Yes. We can talk about CTP. Okay. CTP. This one, yes, you combine the two would be 34 degrees, right? And then CT is 5. Now, what else do we know though? We need at least 3 pieces of information.
Can we find T out? I don't know.
The angle T? Can we?
I don't know, can we?
Yes, we can, because we can use a different triangle. We can use CTM. Right? It's the same angle. Because P is just the extension of that. So that angle can be worked out. That's 9, that's 5, 9, and this is 22 degrees.
Oh, yeah.
And we already found, I think in the previous question, we found, from question B, was between the tower and the mast, which is 4.749. So actually, no, this is 4.749 kilometers. Right?
Yeah.
Then we can easily find the angle T. And as long as we've got the angle T, we can find the angle P, which is going to be that angle, that tiny angle there, and then you add up to 90 degrees, you get to the other one.
Yeah.
Done.
Yeah.
Okay, make sense?
Yeah.
Not gonna go through this one, too easy. Okay, once you see it, you should be able to work through it.
Yeah.
So please go back and try to work through these questions. Okay, let's see. Do we have okay, actually I'll finish this one because this is the last question about trigonometry. The second half will be about probability. Yeah, about probability and statistics. Okay, last questions on trigonometry, complex unfamiliar in unit 9 here. Vertical tower height 10 meters standing one corner from the top T, angle of depression to the nearest corner B and D is 32 and 19. Again, it's a bit hard to see all of this, so I will draw the basic questions here. And then let's see, the last question is angle of depression from T to the corner C. The reason why I'm scanning is because if I draw TB, I'm sure there will be TC, right? Like surely if they give you a point C, there must be like a thingy TC there, angle of elevation. Okay, now let's draw out everything that we know, but in the form of right angled triangle, so we can solve them. A, B, T, the height is 10. Okay, a rectangular courtyard. From the top of the tower T, the angle of depression to the nearest corner B and D is 32 and 19. So that's 32. And then if I were to redraw it, T, A, and then this is B. Sorry, this is D. So this angle would be, at D is 19 degrees, right? And the tower is 10. So we can find AB and AD. It's a rectangular courtyard, so AB will be CD and AD is the same as BC. Okay, so yeah, they asked us to find AB and AD, it's obvious. So this is actually not too hard, I don't know why this is complex unfamiliar. Anyway, so yeah, this one you would get sine of 32 degrees would be 10 over AB, right? So then AB would be, just punch it in, 10 divided by sine 32. 10 over sine 32 degrees is 18.8708. Okay, which then it will be 18.87 meters to 2 decimal places. Okay, and then same thing, sine of 19 degrees is equals to AD over 10. So then AD would be equals to, same thing, instead of sine 32 would be sine 19. So that would be 30.7155. Which is then AD would be 30.72 meters. That's it. Question A, B done. But I'm on the right question, right? Oh yeah, sine is, sorry, wrong one. It's opposite adjacent, my bad. It's tangent. Why did I say sine? So weird. Tangent, yeah, my bad. So it will be inverse tangent, not 10 over tangent, not sine. Whoops. Okay, so that would be 29.0421 to 29.04 meters. Yep, my bad, it's tangent. There's no hypotenuse. Okay, so please do not make the mistake in the exam. Okay, this is what happens when you do too many questions. Alright, so that'll be 16.0033, which is 16.00 meters. Okay, yeah, that's better. Alright, next is the angle of depression from T to the corner C. Now, T to the corner C means we need another triangle. Alright, TAC. So first we actually need the triangle ABC. Right, because it's a rectangular courtyard, so B, C, A here, and then D. So we found AD, which is 29.04, and AB is 16.00, so we can find AC. All right, and then using AC, we'll be able to find the angle of depression. Yeah, it should be obvious, right? Like these questions are not hard.
Yeah.
So AC would be square root of, again, to use more decimal places, 0421, nearest degree, oh yeah, that's fine, squared plus, okay, definitely hypotenuse, yes, 16.0033 squared. Okay, so then AC would be, punch that in, so that'll be 33.15945 meters. Again, they don't ask me for the size, so I'll just write more decimal places. Because inside here is like 5 zeros, so I just chop at 5. Okay, anyway, and then I draw another one, TAC. So now I know this one, 33.16, and then this is 10. Then we need to find this angle here. So theta, therefore tangent theta equals to 10 over 33.15945. You see how I'm alternating between the more decimal place and less decimal place? You gotta think of it as the same thing. Like in my mind, I see them as the same number. I just extend that or shorten it.
Yeah.
Alright? Or use the extended version or shorten the number. So then theta is just again inverse tangent, you don't even need to write that. So inverse tangent of 10 over 33.15945 is 16.7819, and then to the nearest, what is it? To the nearest degree. So theta would be equal to 17 degrees to the nearest degree. That's it. Okay?
Yeah.
Not too bad? Yeah, so these are, I would argue that these are the easier complex unfamiliar. I think the complex unfamiliar we did in the last chapter of this, the 3D one with the angled plane and stuff, those ones are much harder. This isn't easy.
Yeah.
Right, so don't fool yourself in thinking that the exam is going to be this easy. Maybe internal complex unfamiliar if you're lucky, but external will not be this easy. Yeah. But if you guys find these questions easy, good, go back, practice it. Okay, and then I'll stop the first half of the recording now. So Peter, there should be another video in the same link for the second half. And so once you practice these questions, then we can move on to the second half.